This is an interesting piece of kit which I thought you'd like to see. It dates to the latter part of World War II. Beautifully made instrument. Say the case has suffered a bit over the years, but if you pop the latches, it reveals inside the case is a rather beautifully made World War II Wavemeter, which would have been used to calibrate ships' transmitters so that they all would match up and able to communicate with each other without any effort. And before the days of digital readouts, you'd have had to have done this with analog meters. Basically what you have here is all the coils that are made of Bakelite. They work to about 100 Hz to so many thousand kilohertz in in different steps, and you can see they're all numbered and they correlate to the on there, and you just select the right one for the transmitter and plug it in. If I can just whip him out, which is tricky one-handed. There we go. Pull him out gently. Very, very heavy piece of kit. As I say, because it was for the admiralty, it says on the top there admiralty pattern, individually numbered. It's there you go. I'm gonna put him there. We can see him in clearer detail. You have basically a radio receiver, really. It's very, very heavily constructed. It uses a one-valve battery-operated system, which, amazingly, for a valve, it doesn't require HT. It only uses low tension. But in order to get this to work, I've had to modify it to run on a D cell. And if you would like to see it working, I haven't got a ship's transmitter with me at the moment, so what I've done, I've got a metal detector that runs off 18 kilohertz, and I've put a few extra turns into this coil, which is F, which is the least likely coil that you're ever likely to need, so I think I've just modified that one. And you just simply, in the side there, you just plug him in, like so. Ooh. Give it a bit of a squeeze. There you go. And then all you have to do is introduce your radio source, which in this instance will be my metal detector there, which is run on 18 kilohertz. And then you simply need to just switch him on. As you can see, you've got a bit of a deflection on the meter already, which is telling you the valve is warming up. And all you need to do then, with your detector close by, is turn this knob until you get the maximum deflection. You've got a coarse and fine adjustment, so all you do is you simply turn the dial. You can see there that the milliamperes are rising. Not rising very far, but you say the detector is running on low power, so we don't want to overdrive anything. As you can see now, if you use the fine adjustment on the wheel, you can actually get that meter just on the top of its peak. So you can bring the coil a little bit closer and it'll climb higher, but there you go. You can see them in operation there, which I think is pretty amazing. And then what you do then, you take your coil frequency on the top there, and then you take the dial reading, which is in degrees, and then you use a chart which is in the box there, and it tells you exactly what the spot frequency is for the given coil. And it works out about 18.7 kilohertz, which is about right for the dais. There you go. Lovely piece of equipment. As I say, it would have been used in time for D-Day, which was 6th of June 1944. I know that because I've had the dial off to lubricate the component inside, which was a bit stiff. That was dated late 1943, so the actual piece of equipment would have been put together late in 43, early 44, so there you go. thought you might like to have a look and just see how he actually works. So you pull the coil out, put that back in the housing. As I say, it's a 1-valve unit and the battery is no longer available, but if I pull the housing off, I'll switch him off first actually, that'll save a bit of... There we go. You can actually see the workings of the unit. Now inside on the tuning component, which is the other side of that rather large knob, is this rather expensively made variable capacitor. And if you catch the light you can actually see, there we are, it's very, very beautifully made. Basically what that does, the variable capacitance will tune the given coil into an exact match or resonance, so that the coil of the detector or the transmitter will resonate with the unit and cause a small rise in voltage, which is measured in the voltmeter, which you can see the back there. And as you can see, inside is your 1-valve unit, which this one is functioning as a diode valve. As I say, all it needed, instead of the old ever 82-volt battery, which is no longer available, I just soldered simply a D cell, 1.5 volts, and that is sufficient to run the filament. I can actually show you one of those, because in there, in the box, is a spare valve. Now this is original, never been used. As you can see, it's got the wartime military markings on there. It's a VR21. It's a triode valve, but on this occasion only the filament is used. And what the filament does, it heats up, the battery heats up the filament, and the electrons can only flow one way into the grid. So the grid is basically connected together, and it just makes a simple diode, which creates a high frequency into a small measurable electrical current, which is measured by the ammeter. Amazing piece of kit. So, can you imagine them making things of this quality today? Would have cost the military an absolute fortune. Hope you enjoyed seeing it. Thank you.